Hi, I'm Thibaut from MongoDB. Today I want to introduce you to Vision RAG. We talk a lot about RAG for text, but a huge amount of data is actually trapped in visuals. Think charts in PDFs, diagrams in slides, etc. That information can be converted to text using parsing techniques or OCR, but this is brittle and expensive. Vision RAG solves for this by using multimodal embeddings. So I want to show you a simple Vision RAG example. Just like for text RAG, we first need to embed the source data. But instead of embedding text only, we'll use multimodal embeddings from VoyageAI that are able to capture the meaning and visual characteristics of images. In a typical RAG pipeline, you would store the vector embeddings in a vector database, such as MongoDB. And then, at query time, perform a vector search to retrieve the most relevant documents or images in this case, and send them to a vision-capable model so that it reasons over the images. To keep it simple in this example, we'll just store our embeddings locally. But keep in mind that in production, you would need a vector store like MongoDB. In order to show you an example, I need a dataset rich in visuals. I'm going to use the GitHub Octoverse survey from 2025. It contains a lot of graphs about the state of the developer community in 2025, which simulate the type of information typically found in enterprise data. Think complex documentations with figures and tables, slides, etc. Let's get back to the notebook. First, after installing all the necessary libraries and initializing API clients, I need to run a simple script to scrape all the images from the article, and that's what I'm doing here. But then, once it is done, I need to use VoyageAI multimodal embedding model to embed those images. Note that you can embed text and images in the same vector. That's handy for providing a textual description of an image, if you have it, to give it even more semantic information for retrieval. Then, this is where the magic happens. We're not using any OCR or complex parsing heuristics. We're just embedding the images as is. That can be screenshots of PDFs, screenshots of slides, you name it. Once indexed, we can use vector search to retrieve the most relevant images to the query and feed them to a vision-capable LLM such as Claude, which is able to read the images and reason about them so that it can respond to the query. When we define all the different components of a RAG pipeline, such as the vector search and then the generation steps, we can test it on a few examples. The first example is what countries has the biggest developer communities. Using vector search, it retrieves that infographics. And then this diagram actually shows the number of developers in a few countries, India, Brazil, and Indonesia, showing the biggest developer communities. And so we sent that image to Claude, and Claude is able to reason about this image and respond the following. The second example is how many open source repositories are there in 2025. And then using vector search again, we retrieve the most relevant image, in that case, this infographic. And then we send that infographic to Claude so that we get an answer. The last example are what are the top programming languages. Similarly, using vector search, it retrieves the most relevant infographic, in that case, the top 10 programming languages, and then we send that to Claude and we get the following response. So that is really the essence of Vision RAG. No need for OCR or complex parsing. You can just use multimodal embeddings and a model like the Voyage Multimodal 3.5 from VoyageAI and search over those images and feed them to a vision-capable LLM. This opens up a lot of new use cases for searching documents that are hard to parse or extract information from. If you're looking for testing VoyageAI multimodal embedding models, sign up for free to MongoDB Atlas. Thank you.